Custom pattern making began in the 15th century. Until then, clothes were stitched together from small rectangular pieces of fabric straight from the loom. Fabric was too precious to be cut to shape. It was an age before style. Not until the Industrial Revolution and the development of standardized patterns did ready-to-wear garments begin to emerge. Today, garments are designed for a wide range of customers and body types. Apparel manufacturers use fit models and body forms to establish the base size and fit of their garments. Today, apparel manufacturers create patterns in several ways. The starting point is often pattern drafting. In pattern drafting, body measurements are taken from a fit model or body form. The designer uses these measurements to create slopers. Slopers are a set of basic patterns used in the development of styled garments. Other common terms for slopers are basic blocks, master patterns, and foundation patterns. The flat pattern making method begins with slopers. A designer adds style lines and uses flat pattern principles to manipulate the sloper into a styled garment. Designers use style lines to indicate where design elements will be located in the garment. Examples are necklines, seam lines, pockets, or other design details that define the style of the garment. The designer must also add seam allowance to the pattern pieces. Seam allowance is the width between the seam line and the raw edge of the fabric. Flat pattern making is fast and accurate and widely used throughout the industry. Designers often refer to both flat pattern making and pattern drafting as simply drafting. Reverse engineering creates a pattern from a sewn garment. In this pattern-making process, measurements are extracted from a garment, or the garment may be taken apart before being drawn as is, or with modifications, to create a new pattern. When a styled garment is copied from another apparel company, it is called a knockoff. Some designers prefer to use the draping method. In the draping process, designers develop patterns by shaping, cutting, and pinning fabric to a body form or fit model. The designer marks seam lines, style lines, landmarks, and construction details on the draped fabric. Next, the fabric pieces are removed from the body and pattern details are transferred to new fabric. The fabric pieces are sewn into a garment and checked for accurate fit and representation. From this second series of pieces, designers transfer all pattern information to paper and finalize the pattern. Draping is a slower and more costly process, but is useful when designing certain garment types. After the fit and style of the pattern are finalized, a full range of sizes are created from the base pattern. This process is called grading. To do this, the grader starts with the pattern's base size, which was created using the fit model's measurements, and then increases or decreases the pattern dimensions to create smaller and larger sizes. The new sizes must be consistent with the base pattern in both proportions and fit. In many countries, pattern making continues to be done by hand. The development of computer-aided design, or CAD, programs have streamlined many pattern-making processes. Designers use the same pattern-making principles and techniques to create patterns in apparel CAD programs as when creating them by hand. CAD programs allow designers to make quick and accurate changes to pattern pieces. The grading process has benefited tremendously from the speed and ease of CAD. Three-dimensional approaches to pattern design are both generations old and still in development. The apparel industry uses body scanning technology to acquire body measurements, create avatars, and for integration with pattern-making software. Using CAD and full-body scanners, the design and drape of a garment can be simulated on an avatar. Many CAD systems allow designers to make pattern changes to the garment while it's on the avatar. The software then applies the 3D changes to the 2D patterns. Some apparel technology solution providers are developing software that converts 3D body scan data directly to 2D flat patterns. Currently, software is available to extract 2D sloper patterns directly from 3D body scan data. There is a continuing trend in apparel CAD software toward 3D design solutions.